In this tutorial, I will show you guys how to use Tensorflow Object Detection API on paperspace, which is a cloud service that provides computing power with very powerful GPU and in a very low price. After signing in, you can go to Machines and then create a new instance. Choose the server that is close to your place. I'll choose the West Coast, and then we click on the public template and select Ubuntu 16.04 machine learning in the box. You can choose the instant, and then here we choose hourly, and you may need to apply for a new instant. Then we choose storage that we want to use. Here we can choose 100 GB. Then okay. You prompt to a desktop, a GUI desktop, and then you can just Google TensorFlow models, and then click on it, and then you can clone this file to your local directory. Let's make a workplace, and then we can git clone this to our local file. And then while it's finished downloading, we can go to the research and then object detection. Right here, you'll see that there is a setup installation. So the directory is models, research, and object detection. And then we can go to this installation. And notice that there's machine learning in the box, so almost everything is set up. It's including TensorFlow and all of this. And okay. We can go to the directory. So cd models, research, object detection. Oh, actually, in the research directory, and then we want to execute this line and see no errors popping out. And then we also export this Python path, and then we run a test to see if we set it up correctly. And if it's okay, we will see a 15 tests is run, and then okay in the bottom. We will prepare some data for our training process, and then now we have finished this first setup step, and then it's really easy with the paperspace, as you can see. Or for local machine, you can just follow the installation process listed in the object detection GitHub. And then now we'll go to the second step, which is to prepare our data. And here is what you will get after we finish all the process here. And then we can take a quick look of what we will get here. Take a look of the image directory, and then there are two image file. One is train and one is test, and basically they are paired with a XML file like this. And then you also have a test file and also pair like this, image and XML. And then after that, you copy all of them in both file, of the image in both file, and then copy into the image directory. So just like this, and then you split them, like maybe 70% in the training and 30% on the test, depending on how many images you have. In my case, I have only 100, so 70 to 3 is pretty good ratio. Otherwise, if you have many like thousand millions of image, you probably want to like 99% in train and 1% in the test. And then after that, after splitting the image you take of your home, for example like this, you have the object that you want to detect. You can go ahead to, actually you can just split it to these two files, and then you only contain image here without the XML file and image here without XML file. And after that, you go to this link, the GitHub directory, and basically this is software that allows you to label your image. If, like, for example, here you give a coordinate here and coordinate here, and then the class person, and then after that they will generate an XML file just like this. And then you have, for example, a nano leaf, and then you have the coordinate that you can wrap around your object. And then here are some instructions. You can build it in for Windows, Linux, and you can also build from source for the Mac OS, just like what I did. And then after that, you can go to the label image directory right here, and then you can open the label image software, and then just like that. And then you can open your, for example, your test directory, and then all your images loaded here, and you can press W or create a rec box right here, and then just wrap around the object, and then give it a class, and then press OK. And here you can see it's labeled it with the class and then the coordinate, and then you can Command S or Control S, save the image, and it goes to the next image. After that, you will get all the XML file right next to the image, just like that. And then after doing all this for all your training image, so for example here there are about 90 image, and then here we have 10 image, and then we copy them out to the image directory outside it to test and train directory. For the image directory, make sure your photo is downsized to maybe below 1 MB or just a few hundred K, or better below 100 KB, so that you can run faster. But this depends on your memory of your GPU. So after that, let's take a look at what we contain in the data directory. We have a object-detection.pbtxt. Basically, this tells you what item, the class you want to detect. For example, in our case, we have a fan, we have a lamp, and we have another leaf. Just create an item for each of them. Make sure the IDs start from 1, 2, 3. Okay, this first file, and the second file is, those are the Y label for TensorFlow to recognize, for example, test record and the train record, and those 4 files are generated by these 2 Python scripts, and they come from this GitHub directory. You can go to take a look here. Okay, and then basically it's just this 2 file, test XML to CSV, and then test generate TF record. And in this 2 file, we'll make some changes. The first change is basically you iterate through the training and test set, and then you generate the output to the data directory, and then give it a labels, CSV, the name. And then for the generate TF record, you will have to make a change here. Basically, you make a conditional condition on what row label it is, and then output the index. And then you can just run this script to use it. So Python generate tf-record, and then you will have there, because you generated the train label with the previous Python script, then you will have this two label inside the data directory, and then you can output the two tf-record also inside the data directory, just like this. And then okay. And then now what we want to do is take a look at the training. We have a configuration. Here we want to change the number of classes right here. In our case, it's 3. And then also a few more changes in here. Fine-tune checkpoint. You want to start the training process from a pre-trained model. What's that mean is that actually TensorFlow trained some model for us. It's called SSD MobileNet V1 Coco, and there are few more that you can choose from. Just scroll down in the TensorFlow object directory API, and you'll see extras and TensorFlow detection model zoo. And then right here in the Coco trained models, you have many options, and they are ordered by their speed. And obviously, the faster the algorithm is, this less accurate it is. So we'll be using the fastest model, SSD mobile directory, and click on it, and you get this directory, which is next directory we want to talk about. This one, you can just put it inside here. And then the training configuration, we'll set the fine-tune checkpoint to start from here, and then the model checkpoint. So it's here. We want to start from here, that's the model checkpoint. And then after that, you want to change these two, the train input reader and also the evaluation input reader. Basically, you want to change the path to data and train record, which is the TF record you just generated inside the data file. And also pointing to the object-detection.pbtxt, which is specify what classes you have, and do the same for the evaluation input reader, just like that. Then we can close that out. And then now we got all the thing we need. Actually, we only need this 4 and this 3 file. It just help us to generate thing, to generate the image XML file, and also the CSV and TF record, and also yeah, I think basically that's it. Where we can get the SSD mobile net patch configuration, basically is where you download the this file. So it's the TensorFlow detection model zoo, and then after you're finding the model name that you want to use, for example in our case SSD mobile net V1 Coco, after you download that, and then you can go ahead to this link, sample configuration, and then look for the configuration that TensorFlow will work for us. In this case, is SSD mobile net V1 CocoNet configuration, and then we modify the number of classes, and also a few other changes, for example fine-tune checkpoint, and also these 2 paths that we need to configure. And I already configured for you, so you can use this, or if you want to use auto model, you might want to change it yourself. What to do is go to the link below to my GitHub repository, and then you can clone the file I created for you, example file. And then there are 3 classes that we want to recognize, and then or you can replace the image with your own and own image, and then you can make a few changes to make it work for your own data set. Then now we can just simply go to our workplace, and then we can declone the file right here. Okay, like this. Okay, and go to see what we have here, and then these are all the file that we just mentioned, and then these two are helping us to generate the file that we can ignore them, and then we want to copy this for, okay, to our GitHub repository. So it's the models, and then we search, so object detection, then we're going to paste it here. Okay, here there are some files already in the data directory in the models from TensorFlow, and here we just simply merge them. Then let's see what we have here. We added this 4 file in here, and now we want to train our models. So TensorFlow created Python train.python here, and then we can try to open it up, and we'll see that there are some script example usage right here, and then we can go to our we can change our directory to models, research of detection, and we want to try to run it. You can use Python 3 or Python 2, it doesn't matter. And then we want to make a little change here. So here we want to change this path to our training directory. So this will be, we can get the current path by this, and then we copy that by Control Shift copy, and then we can paste it here, just like that, and then we will have here be training like this, so pointing to this file right here. And then for the pipeline configuration path, it should be also the same, except for we are pointing directly to this file. So just copy this, and then no, okay. It's actually wanting the pbtxt file, so it actually is the one that we store in the data point. So it's the object detection pbtxt, which we will talk about before. It's the item 1, item 2, item 3 file, and then here is what it is, and then we want to put it in here. So we change this, copy this, and then instead of detection training file, we input data file, and then object detection.pbtxt. Okay, just like that. And then we just copy this. And then we want Python 3. And let's see what I will get. Okay, cannot open file.train. Oh, okay. So we should also add a py.train here. I don't know why it is not here, but yeah, so okay, copy it again. Control Shift D. Okay, we can see it start running. Go to configure help name and items. Okay. Just got some weird error because the first thing is because I run the train, like the Python script wrong. It's actually not pointing to the object-detection.pbtxt file. It's actually pointing to the training and the configuration file. So if we open up this installation, or you can just go to the model research object detection train py, and then here it's actually pointing to the SSD mobile net v1 pet configuration instead of the pbtxt. I was confused by the original example, and you also need to add a .py after that. And if you run this and get into some error, like getting some non-error, like I forgot the error is like it only allows 0 or 1 or boolean, but none is found, some error like that, you need to modify it. I think it's in the sample. Oh no, it's in the models. It's in the models file in the object detection, and then you found the SSD v1 MobileNet v1 feature extractor. I actually never encountered this error before, but I tried to Google it up and then sees that you need to. Okay, let's see. You need to change something to true instead of false. Okay, it's here in this line. So its training should be here, should be true. The original is none. So you need to change this line and here. Okay, and after changing that, you can just run the script with this on the training file, making some modification like changing to .py and then train directory to be training, and then also the pipeline configuration path to be training SSD configuration. Okay, and if we try to run that, it's loading up the TensorFlow. And then you might get some like CUDA error, out of memory error, because CUDA is trying to maximize the memory that you use for the training, so it might get into some error, and then you shrink it down the size of the memory used in the GPU, and then you start training. And you might notice that here is saying that restore inform. Okay, if you get into some error like this, like GPU devices or something like that, you might want to restart your devices. So I don't know why it's that today. So I never get into this error before, but today I get it. I got this error saying that internal error for maybe something wrong with the GPU, and if you restart your devices, requesting here restart your machine, and then you try to run that again, it might work. And then now we are restarting our machine. Okay, after you restart machine, you can go back into the workplace, and then not workplace, models, research, object detection, and then you run the okay. I forgot the script. It's in the train, and then copy this to the terminal. Do pipeline query. Oh, don't forget to do this. Produce the 2-line before running the script. Okay, the 2-line is protocol. You make sure you do it in the research directory, model research directory, instead of the object detection directory. Then do it again. Okay. Oh, wrong. This line. Okay. After that, let's get into the object detection directory and copy this file, this script, to the terminal, and then make sure everything is good, and then run again. Okay, we can see that the loss is decreasing and the step is running really fast. This only works when you have a GPU, a dedicated GPU on your machine. And make sure if you are running this in your local machine, make sure you install the Tensorflow GPU version, because it just doesn't work in CPU. And then also, if you run into some memory issue, there's some small change you can make. So if you look at the training and the configuration, we open it up, where you can modify the batch size. Here. So here is just like how many image that you pass through in each iteration, like forward pass and backward pass. So here we use 24 images. Make sure if your GPU is suffering, you should lower this number, and also the resolution of your image should be lower, because this actually needs some computing power from the CPU to process the image. So it may also depend on the memory of the RAM of your computer. So make sure your image is small enough. Like I mentioned before, it's like below 100K for better training speed. And then let's take a look on the training. And now we can see, like, after a few minutes, it's already down to like 2. The loss is down to 2. So what this loss is like, it's measured on your test set that you have beside the training set, and then at each step, we run the whole network on the test set that you separate from the training set, and then you can see the error, the loss is fluctuating, but it's kind of going down to 2 or 3 in just a few minutes, and after a few hours you probably stable at 1, and then after that you can quit. Okay, we probably just let it sit here for a few hours. And I'll also mention that we can actually enter the terminal view, and the password for the terminal view is send it to your email, so you can use that for maybe you're more familiar with the terminal. 3 minutes of training, you can just simply run the code. You can run tensorboard log dirt directory equals training, where all your checkpoint is stored to your training file, and then you can go to your local host 6006, meaning Google, GOOG, and then you go to there. You can see that how your training is running right now. You can look at the total loss is decreasing, and then you get update I think it's every 3 or 4 minutes. Then you can see the lowest checkpoint is stored into in the training directory. You can see the checkpoint A68 is stored, and then if there is a lower total loss, the checkpoint will be stored in the training directory inside the object detection. So it's right here. So each time you try to exit from the training, so for example, you want to stop this training. Now it's running around 900 steps. You want to stop it. TensorFlow will automatically restore and train it again. Will restore from the checkpoint that you have in the training directory, right here. Happy with our training. The result of the loss of our training. We can see that there's some checkpoint. The last one, like make sure you have all of them, like the meta index and the 000 of 001, something like that, and then you make sure 3 of them are here, and then you can choose the last one. For demonstration here we use the A61, and then we go ahead to open up the export inference graph python.py in your object detection directory, and then we make some change for the example usage. So first of all, you add a .py after the export inference graph, and then you leave this line the same, and then you also want to change this path to training because our configuration is inside the training directory, and also our checkpoint is also inside the training directory right here. So you see that is 861 step at, and then we can modify here just like this, and then here we want to make a directory for the graph that we export. So any directory, for example home inference graph, just like this, and then this Python script will automatically generate the output directory for you, and then we can just copy this. Okay, you can just copy this line to our terminal and then run it. Okay, so this just means we haven't export this path in our terminal. You can also change it into the profile in your local. So you go here, and then you can I think it's in the profile. You can edit this directory in this file, and then add this to here. So, but in this tutorial, I was just going to use my old terminal and then copy that here and then try to run it. Okay, we see that we forgot to change this to the name that our configuration is. So it basically is SSD MobileNet v1 pet. That's not the inception. So right here should be this file instead of a default one. Okay. And now we see that we have this file right here, and then we can just simply use this in the example code iPalfa notebook given by the TensorFlow. It's right here. We can go ahead and open that up. Object-detection.py. And then in here you can see that now they are using the MobileNet that they load from the they download from the internet, like here, download from their website. But we can instead change it to our home inference graph, like this, and then the model's name will be added here, and then we don't need this too. Yeah, I think we don't need this too. And then we automatically find our frozen graph, and then we want to change this to 3, and then also notice that here we want to change it to object-detection.pbtxt. Make sure the name is correct. So inside the data we find the one we talk about. It's like 3 item 1, 2, 3. The fan, the nano leaf, and the lamp, and then we don't need this one. That, and then yeah, that's pretty much it. And then you want to load up your test image into the test image directory, and here you simply iterate through the image directory, and then you just add your custom image here, or you can use CV2 to make some streaming detection and with some modification in here. And we can see that actually this code is highly inefficient because I just want to show you that another model that I used to train our object detection, custom object detection. You can see that I used the graph faster, like faster RCNN, Inception v2. This is architecture, and then we skip the download model, and then we see that here we will iterate through the image. So I throw some test image inside the test image folder, and then skipping the first 2, the default image, and the rest of them are our custom image. And then we just run this code, and then notice that I use CV2 to import the image. And then we also instead of creating a section each time and a graph each time, we move it to here. So this will make the algorithm run much faster. And then we see that we finished running, and actually this model is actually slower than the MobileNet, but it's more accurate. You see that there are some error. but it's pretty accurate. Even with a small object appear in the image, you can still detect it with a high accuracy. Just like this. And you can also try to close the light and open the light, and you can still detect it. Alongside your data has this variation. You can try to take the picture in different angle and then different lighting and different distortion, and this will improve your accuracy in real time. Thank you guys for watching. If you have any questions, please leave in the comment below.